Incredible progress in text-to-video AI, ChatGPT surpassing doctors in competence and empathy, MIT creating liquid neural networks that could become universal brains for robots, and NASA developing a robot to search for life in the oceans of distant Enceladus. All of this and more high-tech news, all in one video. So, do you remember the video created by artificial intelligence in which Will Smith eats spaghetti? It was done more as a bit of fun than anything else, but nevertheless, the technology that created it is advancing rapidly. The new AI for text-to-video conversion from NVIDIA first generates video from text and then refines it using animation training on thousands of existing clips. The model estimates what might change in a particular part of the image over a period of time, then creates a sequence of frames, and finally creates images of the same quality for each frame in the sequence. The team used the system to create multiple sample videos at 1280 by 2048 pixels, simply from text cues. Each of these videos contains 113 frames and is played back at 24 frames per second, so they're about 4.7 seconds long. Now, of course, there are still a lot of errors and other oddities in them, but in terms of image quality, this is an incredible leap forward from what we saw with ModelScope earlier this month. The rate of progress suggests one thing, that AI will soon be able to generate very realistic videos from any text. At this rate of AI development, the future may indeed be more interesting than any predictions. ChatGPT continues to amaze researchers with its capabilities. Researchers at the University of California, San Diego, have tested ChatGPT to give online advice on medical topics. Now, in this case, the idea was for the chatbot to actually replace the doctors. The results of the study are unequivocal. The neural network not only gave more detailed and clear answers to questions, but it also showed much more empathy for patients. Although perhaps the latter might say less about the empathetic nature of AI and more about the lack of empathy on the part of the doctors. The questions for the experiment were taken from the website Reddit. There's a special service called Ask Docs, where users' questions are answered by professional doctors with proven qualifications. Results of the experiment are, to say the least, stunning, or maybe depressing, it depends on how you look at it. I say that because the answers from the neural network were, amongst other things, of higher quality than those from the doctors. Moreover, the evaluation was conducted by medical experts who did not know which answers belonged to the doctors and which belonged to ChatGPT. So, as a result, the experts preferred ChatGPT's answers to the doctor's answers 79% of the time. And at the same time, the AI's level of empathy was 45% and the doctor's was less than 5%. But don't get too excited. We mustn't forget that ChatGPT is more than capable of producing outright lies and hallucinations. And it has to be said that without special education, you're unlikely to be able to distinguish nonsense from truth every time. So for now, have patience and make an appointment with a doctor if you have a medical complaint. While everyone's going crazy about ChatGPT, researchers at MIT are developing revolutionary liquid neural network technology. While conventional neural networks learn by example and don't adapt well to changes in input data, liquid neural networks adapt easily to them in real time, significantly improving their ability to analyze unpredictable environments. In other words, thanks to liquid neural networks, robots and drones can potentially make reliable decisions in new and unknown situations. For example, if such brains were given to the Atlas robot, it could show parkour or serve tools at a construction site rather than just in a prepared lab. Scientists at MIT demonstrated this on a drone that had to follow its target in unfamiliar conditions, relying only on vision. Our experiments show that we can effectively teach the drone to find an object in the forest in summer and then deploy the model in winter in urban environments with different tasks such as searching and tracking, the developers told us. In other words, the new class of algorithm is capable of capturing critical causal relationships, separating important and unimportant aspects from the changing incoming data stream. So, this new technology in its development can solve all existing application issues not only for drones, but also for unmanned transport and robot systems. The Artificial Intelligence Division of Google DeepMind showed humanoid robotic soccer players, which it turns out are being developed there. And the developers have declared that this is the real embodied intelligence. That is, if ChatGPT operates in the digital space, then these robots are its analog in the physical one. But don't be too quick to laugh. These robot soccer players differ from their counterparts, who are usually rather clumsy. They are not afraid of physical contact, they don't try to avoid collisions, and they're able to get up quickly, and most importantly, they're incredibly goal-oriented. So, do you think we're on the verge of seeing real-life Terminators, or does it still look a bit lame? Nauticus Robotics is taking its underwater robot transformers out of the lab and into the real world. 3 Mark II aquanauts will head to the North Sea and the Gulf of Mexico in the coming months to do work for the company's clients. The Aquanaut Mk2 is an all-electric, unattached and autonomous underwater robot that is controlled by an acoustic communication network and relies on artificial intelligence software. It allows the robot to act autonomously, performing a number of tasks without human involvement. And if necessary, the operator can connect through a user interface. The boat-shaped robot can swim and collect data using onboard sensors. And if intervention is needed, Aquanaut will deploy its 2 electric arms and do what needs to be done, with high precision and force control. And it's not just a trivial set of underwater infrastructure. The Nauticus team believes it can turn the outdated ocean exploration industry entirely on its head, believing that the unexplored depths of the ocean have more potential than space exploration, for example. And which do you think is more important, conquering the moon or exploring the ocean depths? Meanwhile, NASA's Jet Propulsion Laboratory has created a self-propelled autonomous robotic snake designed to explore extreme extraterrestrial landscapes such as Saturn's icy moon, Enceladus. So what's unique about Enceladus is that beneath its crust of ice, it has an ocean of salt water that constantly ejects plumes of icy particles mixed with water and simple organic chemicals into space. The Exobiology Extant Life Surveyor, EELS for short, robot is 4 meters long and weighs 100 kilograms and consists of 10 identical rotating segments that use propeller heads to move and grasp. Given the communication delay between Earth and deep space, EELS must be able to operate and solve its difficulties completely autonomously. The robot is equipped with 4 pairs of stereo cameras and LiDAR to create a 3-dimensional map of its surroundings. LiDAR determines range by targeting a surface or object with a laser and measuring the time it takes for reflected light to return to the receiver. EELS uses this information to create navigational algorithms to make it easier to traverse difficult spaces. To test EELS' mapping capabilities, last year the JPL team dropped part of the robot into a vertical shaft on the Athabasca Glacier in Canada's Rocky Mountains. The final form of EELS will contain 48 small motors which will provide more flexibility. Many of them will have built-in force and torque sensors that will allow EELS to feel how much pressure the robot segments are exerting on the terrain. This will help the robot navigate over uneven surfaces in tight places. Next, engineers will need to add a number of research tools to the robot. It should be ready by next autumn, but it won't fly to Enceladus for a while yet, I think. Swiss startup Elethor unveiled its Morpho drone with transforming wings that adapt to reduce wind resistance. The drone has a bullet-shaped aerodynamic body with 4 propellers, as well as 4 wings. Each wing can rotate independently of the main body. On the ground, the drone stands upright with its wings tilted down to keep it upright. It then takes off like a quadcopter using feedback from onboard sensors to adjust the angle of each wing and reduce exposure to side winds. If the drone needs to move into the wind, it unfolds its wings and uses them as a sail, thereby saving on energy consumption in flight. The position of the wings is automatically adjusted by the controller, and it's hoped that Morpho could eventually be used to inspect such things as power lines, power plants, wind turbines, and offshore oil platforms. And because its wings can be pulled close to its body when it hovers, it can get very close to obstacles during inspections. As it moves between inspection sites, it can switch to faster, more energy-efficient flight with a fixed wing. The University of Texas Robotics Laboratory has also taken up humanoid robots, and lately it appears everyone has been developing them. So the developers hope to create a universal robot based on their research robot Draco 3 to help in the home and office. Well, let's wish them luck. And although this task is rather, let's say, impossible now, sooner or later everyone is probably going to have this sort of robot at home, just like they have a computer or smartphone. Human fingers are not as simple as they seem. They have an unbelievable degree of dexterity and sensitivity, and this is well understood by developers trying to replicate them in robots. Right from the off, there are 2 major problems to solve. First, to create a design that will accommodate everything that is needed while maintaining a size which is close to that of a human finger. and second, to give the robot a mind to control the design. So researchers at Columbia University have tried to solve this problem, and they have taught robotic fingers to perform dexterous manipulations of complex objects without dropping them, and to do so solely by touch, that is, without any feedback from vision. So the question is, how are they built? Well, under the skin of each finger is a flexible reflective membrane, and underneath that is an array of LEDs and photodiodes. Each LED turns on and off for a fraction of a millisecond, and the photodiodes record how light reflects off the inner membrane of the finger as it deforms. The trained model matches this pattern to the location and amplitude of the finger touches. The second component of success is reinforcement learning, which gives robots the ability to evaluate an object by touch to see how best to pick it up, or indeed whether it's possible, at least in principle, to pick it up in the first place. ClearPath Robotics, a Canadian company developing transport carts for industry, has decided to expand the market for its robots and suggests using them at home. For this purpose, the engineers installed the Franco Research 3 robotic arm with force sensors on the mobile platform Husky, so it can handle both heavy and fragile objects. The robot can move on its own, but other functions it will have to learn by itself. I'll leave it to you guys to rate the usefulness of the invention on a scale of 0 to 10. Interest in flying cabs has come and gone because of the problems with range and safety and regulation and so on. Nevertheless, engineers are still working on them. Terradynamics, for example, has developed a vertical takeoff and landing vehicle that takes off like a helicopter and flies like a plane, all thanks to transforming wings in flight. The electric Transwing XP4 takes off with 4 propellers, hovers, folds its wings and then flies like an aeroplane with 2 propellers right up to the landing site. This allows a 2-meter apparatus with a wingspan of 4 meters to increase its range due to the lifting power of the wing. By the way, many companies tried to solve this problem, but so far it appears only Terradynamics have succeeded. While the Transwing XP4 will be tested to deliver cargo from ships to shore, in the future, of course, the creators dream of a fleet of flying cabs. The Dira Robot Brag exhibition was held in Denmark, organized by the Danish Institute of Technology and the Danish Industrial Robotics Association. The purpose of the exhibition is to draw attention to robotics and to accelerate robotization in the country. We've selected a few interesting projects from the exhibition for you. For example, the Institute of Technology presented at the exhibition its part of the project for NASA to return Martian soil to Earth. Institute engineers are working on a vision program for a robotic manipulator that will work directly with the samples. Robka has unveiled its Arthur robotic scanner, which stands for Arthritis Ultrasound Robot. Using advanced ultrasound scanning controlled by artificial intelligence and providing high image quality controlled by AI, the robot can examine patients for rheumatoid arthritis and independently generate reports for patient records. This technology allows for early diagnosis of rheumatoid arthritis and enables large numbers of patients to be scanned without the presence of a specialist. Seasite Solutions has introduced an autonomous lifting positioning system for wind turbines. It can independently and safely lift and correctly orient wind turbine components without human intervention. The system is simple and versatile enough to work with other parts and structures as well. Don't forget to subscribe to the channel. Now, as far as I'm concerned, the future will undoubtedly be more interesting than any of us could possibly imagine. So join us for that bumpy ride.